Okay, this second part we're going to get into now in this chapter, we're going to be dividing polynomials. So in other words, how to do long division. Now, you probably remember the long division algorithm, like how to divide something into something else. Now, remember back when you had to do this by hand before you could use a calculator? Okay, think about it. The divisor was the number that was doing the dividing. It was out front. So the 4 is going to divide into 1345. Now, yes, I know you can plug this into a calculator, but let's think about the steps, right? So how do we actually do this? You say 4 divides into 1. No, 4 does not divide into 1. It's because it's smaller. However, 4 will divide into 13 3 times. So you go 3. 3 times 4 is 12, and you put it underneath. And then what do? You subtract. Subtract 1. Okay, now you notice I put it right above here because I didn't put it above the 1. It goes into 13, 2 digits. Now, 4 won't divide into 1, will it? However, this is where I bring down the 4, boop, boop, and start over. I do the exact same procedure again. So 4 divides into 14, once again, 3 times, because 4 times 3, right? 4 times what will give me something really close? It's got to be 4 times 3. Now, I could go 4 times 2 or 4 times 1, but that's not helpful. 4 times 3 is 12, and then I subtract. 4 take, this is 2. Bring down the 5. Now I know that this is my last step because there's nothing else to bring down, right? There's the decimal right there. Okay, so 4 divides into 25, doesn't divide into 25, but it will go in 8 times. So 3, 3, 8. 4 times 8? No, no, hang on, hang on. Let's make sure we get this right. 4 times 6. Come on. Okay, there we go. 4 times 6 is 24. There we go. See, it's pretty close. 24, 1. Now, normally you could put in a bunch of zeros and we could do a whole bunch of decimals. However, when we do this in polynomials, these are no longer going to be numbers. So you know what? Typically, when you first did these, you were done and you said, oh, hang on, there's a remainder of 1, right? This is called the remainder. So you would say the answer is 336 with a remainder of 1. In other words, there's 1 left over. It didn't go in perfectly. Okay, so the divisor is the number out front. In this case, it's the 4. The dividend was the number inside here. It's the bigger number. And the answer you get is called the quotient. Oh yeah, that's right. Quotient. The answer, the quotient is on top. And you may have a remainder plus a remainder on the end, right? Yeah, so now you could check your result with this multiplication. So the opposite of doing division is multiplying. So if I was going to multiply this out, I would take my divisor and I'd multiply it by the quotient. So I would go the quotient times the divisor, right? Let's go, yeah, quotient times divisor. So if I multiply those two out, hang on, let's try it. If I go 336 times 4, 4 times 24, carry the 2. 12 and 2 more is 14, carry the 1. 12 and 1 more is 13. Oh, hang on, 1345. Oh yeah, there was a remainder 1. I have to add on that 1 afterwards, right? So 1345, that's what we started off with. So if I go the quotient times the divisor and I add on the remainder, I get the original dividend. Okay, I get the big dividend. I'll do this as a capital D, dividend. So that's what I would multiply out. I would take the divisor times the quotient when I multiply those two, and then I add on the remainder, and it should take me back to the dividend in here. Okay, so that's doing it with numbers. We're going to do the exact same thing, but now we're going to do it with algebra. So the exact same division and the exact same multiplication polynomials. I know how to multiply out polynomials, but I don't know how to divide them. Okay, well, let me give you a hint. Let me show you something here. X minus 4 can divide into this thing. But here's the thing. This is a binomial, right? This is two terms. Here's what we want to do. What we're going to do is we're going to ignore this 4. Don't worry about it. Pretend it's not there. Just look at the x. Now, my first step up here was, how many times does 4 divide into 1? No, but it will divide into 13, right? So I want to think, how many times does x divide into 3x squared? In other words, x times what would give me 3x squared? Well, I know it's got to be 3x, right? Yeah, because it divides in 3x times. Now, I can't really just ignore it, but I'm going to pretend I'm only looking at the x. X divides into 3x squared, and I put it up here. 3x times. Okay, now remember, I said the 3, and then I multiplied by 4. I put it underneath, and I subtracted. That's exactly what we're going to do. I'm going to go 3x times both of these, times this binomial, and I'm going to put it underneath here. Okay, so 3 times, this is going to give me 3x squared. And 3 times minus 4 is going to give me minus 12x. Okay? Subtract. 3x squared minus 3x squared is 0. Gone. So what's 2 minus minus 12? Think about it. 2 minus minus 12 is going to be 14x. Right? Okay. After I did that, I brought down the 4. Let's do the exact same thing. Bring down the 5 because this is a binomial, right? Think about it. This is a binomial. I need a binomial here, right? That's why I did this binomial here. So I'm going to bring down the 5, minus 5, and start over. X divides into 14x times plus 14 times. So 14 times x. 14x squared, or sorry, 14x. 14 times minus 4, so this is going to be minus 56. And then subtract. Negative 5 minus minus 56. Hang on. Minus 5 minus minus 56 is like saying minus 5 plus. This is like saying 56 take away 5. Positive 51. There's nothing else to bring down. I know. I'm done. That's my remainder. Oh, okay. So in other words, here's what happened. When I divided this divisor, x minus 4, into this polynomial, this big dividend, I ended up getting that as my quotient plus the remainder. So in other words, if I want the quotient times the divisor, let's try it. The quotient, which is 3x plus 14, multiply that by x minus 4. X minus 4. And then when I'm done, I'm going to add on the remainder. I'm going to add on the 51, but we'll do that afterwards. Okay, let's do this. What do we get? 3x squared minus 12x plus 14x. 14 times minus 4. Minus 56 plus 51. Okay, so what do we get? I got 3x squared plus 2x. And 51 minus 6 is minus 5. That's what we started with. 3x squared, 2x, and minus 5, 3x squared. That's the original dividend. Well, actually, we're going to call that the polynomial, right? Because it's the biggest one, polynomial. Because there's a whole bunch of different polynomials here. However, this one is actually called the divisor. The answer you get is actually called the quotient. And this, the dividend, the biggest part, we're going to call that the original polynomial. So this works. How did I get that to work? Well, here's what I did. I ignored the 4, right? I did. Pretend it's not there. I only looked at the x because I wanted the x to cancel out. 3x, all right, I went 3x times x. This makes it exactly the same. So these two always cancel out every single time. And then that basically shifts me over to x and x. So the x squared term is gone and it turns it into an x term. Once I bring down the 5, I can just start over. Now x goes into my x term. 14 times. This one cancels, right? And I'm left with a number. And the number on the end quite often is going to be your remainder. Okay, so let's try this one. Divide this polynomial. P of x is 5x cubed, 10x, minus 13x squared, and minus 9 by x minus 2. So first off, let's do it wrong. I'm going to do this wrong. So yeah, don't write this down, right? Something bad's going to happen. 5x cubed plus 10x minus 13x squared minus 9, right? I'm just looking at the x. So x divides into 5x cubed how many times? Well, it goes in 5x squared times, because 5x squared times x, 5x cubed, 5x, so minus 10x squared. And you'll notice that these two cancel. However, these two, I can't combine them because this is an x term and this is an x. Oh, really? This one, I should have put it over here as minus 10x squared. But so then I'll be doing this one. And then I'm going to have to bring that down and put it over here. And this one's going to have, you know what? These are in the wrong order. For that reason, let's just not bother doing all this. No. Get rid of that, get rid of that, get rid of that, get rid of that. Put them in the right order. This is why it's so important to make sure they're in the right order. 5x cubed minus 13x squared plus 10x minus 9. Now it's in descending powers. 3, 2, 1, 0. Now it'll actually work, okay? So if you notice that they're in the wrong order, it is important. It is important that you put them in the right order. Okay, so now we can actually do this. X divides into 5x cubed, 5x squared times. 5x squared times both of these and put them underneath. So here we go. So 5x cubed minus 10x squared. Now they match up. These are gone. Minus 13 minus minus makes this plus, so minus 3x squared. Now, this is a single term. This is a binomial. I need to bring this down. Plus 10x. There we go. Now I can start over. X divides into 3x squared, minus 3x squared, minus 3x times. Minus 3x times both of these, put them underneath. Minus 3x squared plus 6x, and subtract. Gone. Right? These cancel every single time because I'm setting this up to cancel only the first one. This one cancels. 10 minus 6 is 4x. This is my last one. I know this is my last step because there's nothing else to bring down. So minus 9, here we go. X divides into 4x plus 4 times. So 4 times both of these and put them underneath. 4x minus 8. Subtract. 4x minus 4x, gone. Minus 9 minus minus makes this plus. This is negative 1. So the remainder is negative 1. Okay, so that's my remainder. So if I had to actually multiply this out, I would go the divisor times the quotient plus the remainder. Yeah, so I'm not actually going to do this, but we know that I would go this times 5x squared minus 3x plus 4. And then when I'm subtract that, I'm going to go minus 1. So if I expand this all out, right, 1, 2, 3, this is the water bomb method. Yeah, 1, 2, 3, 4. I have 6 multiplications. I should end up back with this big polynomial that we started with. Okay, so are there any restrictions? Yes, because this thing is being divided by x minus 2. That's like saying the big polynomial is being divided by x minus 2. Oh, that's right. The divisor, the bottom, cannot equal 0. So in other words, just look at your divisor. Whatever's on the bottom, x cannot equal positive 2. That's my only restriction. And then it says write the corresponding statement to, oh, okay, yeah, so that's this here. So this would be x minus 2 times 5x squared minus 3x, careful, plus 4. If I expand that all out and I add on the remainder, which is minus 1, it should get me back to the original polynomial. And the original polynomial was this. 5x cubed minus 13x squared plus 10x minus 9. Now, quite often what they're going to do is they're going to have some kind of shorthand notation for this. They're going to call this the quotient. By the way, it's a function of x. Plus the remainder. Should tell you the big polynomial of x. And this is usually called the divisor. But it's going to be x minus something, right? So it's usually x plus or x minus something. So really this would be the divisor, which is a function of x. So the divisor times the quotient plus the remainder will be the big polynomial. Let's try this one. 4x, there's no x cubes. Once again, here's the wrong way of doing it. Something bad's going to happen. 3x to the 4 minus x squared plus x plus 6. The wrong way of doing it. Let's see what's going to happen here. I'm going to get x divides into 3x to the 4, 3x cubed times, right? Think about it. X times what would give me 3x to the 4? I know I'm really just doing divide by this thing because I know I want it to cancel. So this multiplies by both of these two, put them underneath. 3x to the 4 minus 3x, no, minus 6, minus 6x cubed. These don't match up. I can't subtract these two. No, this isn't going to work. Unless I want to have, this is going to become minus x squared plus 6x cubed, which is in the, it's kind of in the wrong order. You know what? Before, what we did is we said, let's switch up the order. Let's switch up the order before we actually start it. Well, here's the other thing. There's something missing in between. There's the 0x cubed. You need to have that in. Think about this. If I gave you a check for $15,000, that doesn't look like 15,000. 15,000 is 1,000, 15,000, 0 hundreds, 0 tens, 0 ones. That's 15,000, right? So the zeros are important. So let's do that. Let's put them in. I need to put in 0x cubed. You need to have it as a placeholder because it's a place. Okay, and then x squared and then x to the 1. Yeah, now I can do this. Minus x squared plus x to the power 1 plus 6. 4, 3, 2, 1. They're in descending powers, and I've included my placeholders. Now let's try this. So what do we got? X divides into 3x to the 4, 3x cubed times. Well, that's pretty easy. 3x times both of these. Whoa, that's not what I wanted. That's what I wanted. I want them right here, and I'm going to put them underneath. Okay? So 3x to the, come on, give me my pen back. Why are you not working? Work. There, okay. 3x to the 4 plus minus 6, right? So this is going to be minus 6. Minus 6x cubed. When I subtract, these two cancel every single time. That's what I want. So 0 minus minus is going to be positive 6x cubed. Binomial, I got to bring this down. Minus x squared, and I just start over. X divides into 6x cubed plus 6x squared times. Remember, it's just the first one I don't want to cancel. I don't care about the second one. So that's why I'm not matching the 6 up with this one. I want it to match up with the x. Okay, so 6x squared times 6x cubed. 6 times minus 2, so minus 12x squared. Subtract. These two cancel. This becomes positive 11x squared. Bring down the x, plus 1. X, sorry. 11x squared x, this should be 11x. Notice it's also coming out in the right order. X cubed, x squared, x. If I have them in the right order here, they should come out in the right order. Okay, here we go. So 11x squared minus 22x, subtract. This is going to give me 23x plus 6. I know this is my last step because this is the last thing to come down, right? There's nothing else to come down. Okay, so 23x plus 23. So 23 times x is 23x. 23 times minus 2 is going to be minus 46. And I'm subtracting. And 6 minus minus is going to be plus. This is 52. There's my remainder. That's the remainder. And this is my quotient. This is my divisor. Okay, so hang on. So now what's next? Oh yeah, down here it's going to say express it in this form. The polynomial divided by, this is actually the divisor, x minus a. See, in this case it was x minus 2. Okay, that's usually called the divisor. By the way, we probably want to have it as 1x just because it's easier for factoring, right? So this is equal to the quotient plus the remainder over what? What are you talking about? Look at this. Remember, the polynomial is the divisor times the quotient plus the remainder. Well, what if I said, what's the polynomial divided by x minus a? In other words, that's the divisor, x minus a. These two cancel each other out. It's the quotient plus x minus a. Oh yeah, the polynomial is the quotient plus the remainder over the divisor. Remember way, way back in the very, very first ones? These questions up here, you had the remainder of 1. You have the option of giving your answer, which is 336, remainder 1, or 336 and 1/4. Because it's 1 out of 4. There was 1 left out of 4. Remember, this is how we turn these things into decimals, right? The answer was 336. The remainder was 1. There was 1 left out of the divisor of 4. That's where this comes from. So that's what we have here. The remainder over the divisor. And the quotient was the big number. So in this case, my polynomial, which is this big beast, I'm going to be too lazy. I'm just going to write it all out. Polynomial divided by x minus 2 was, what was my quotient? 3, 6, 11, 23. It was 3, x cubed, 6x squared, 11x plus 23. That was my quotient, right? That was the answer? Yeah, 3, 6, 11. And then what was my remainder? 52 out of the divisor. So plus 52 out of the divisor, x minus 2. Ta-da! That's just a different way of writing it. So sometimes they'll say the polynomial is the quotient times the divisor plus the remainder. Or if you divide them all by x minus a, you can see this is just a different form. X minus a, x minus a. See? These cancel. You're just left with the quotient and the remainder over. So things to note: if they're in if they're in the random order, you have to reorganize. I want these in descending powers. It's important, right? Because just like the first one, the leading coefficient actually meant something in the last one. I want these in descending powers because I want my answer to come out in descending powers. So if there are missing terms, you insert a 0. 0 as a placeholder. It's important, right? 101 is not this. This is 101. There's a 0. Okay, that's terrible. So you can summarize the polynomial, the quotient, the remainder, and x minus a. Remember, this is the divisor. You can write it like this one. The polynomial is the quotient times the divisor, x minus a, plus the remainder. Or you could write it as the polynomial being divided by the remainder, or the divisor, x minus a, is equal to the quotient plus the remainder over x minus a. They're the exact same thing. Really, it's just two different ways of writing it. Okay, now, this was a big, long question, right? Now, luckily, I put these all in order. And x to the 4, x to the 3, x to the 2, x to the 1. X, 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 x. You know what? Because I know them, well, actually, I should put that in as a 1. And a 1. Go away. I could have actually just written these as numbers. And you know what? These, come back, as numbers as well, right? And in fact, I didn't even need this x here because the x always canceled. If I was to go through this entire procedure by not writing the x's, man, this is huge. This is a mess. I'm kind of getting lost here. I could have done this entire thing if I knew that they were in the right order and I didn't write the x's. That's what I'm going to do here. This is called synthetic division. Synthetic means it's kind of fake, right? So this is not the true long division. So it's not long division. It is short division. It is way faster. Let's do the exact same thing. 5, 10, negative 13, and 9. Oh, hang on. Was that this question? Is this the one from before? Oh, yeah. 5, 10, negative 13. Oh, yeah. I erased all the wrong x's in the wrong place. Watch. I'm going to do this exact same question, but instead of going 5x cubed minus 13x squared plus 10x to the 1 minus 9, I'm not going to write the x's because I know that they're there and they're in the right order. Okay? And in the same way, x minus 2, I'm not going to put an x minus 2 out here. I'm just going to put a minus 2. So in other words, here's what I've done. I've intentionally dropped out all the x's. Really? Really. 5 comes down. 5 times negative 10, subtract. 13 minus minus 10 is minus 3. Negative 2 times negative 3, positive 6. Subtract. 10 minus 6 is 4. Negative 2 times 4 is negative 8. Subtract. Negative 9 minus minus 8 is plus 8 is negative 1. 5, negative 3, and 4. That was our answer here, wasn't it, from this previous question? 5, negative 3, 4, because they're in the right order. X squared. There we go. There's my quotient. There's my remainder. What? That was pretty quick. I didn't write any of the x's. It's the exact same thing. The negative 10 and the 6 and the negative 8, those showed up. Where is it? Back up here. See, there's the 6, there was the 8, there's the negative 10. They're all there. These are all parts of this. It's just that I'm not writing them all down. It's kind of like cheating. However, let me show you an even better way of doing this. It's all the exact same steps. I'm subtracting each time. However, let's redo this again. Let me show you a faster way. This is called synthetic division. This is how we're going to want to do these. I bring this number down, I multiply, I bring it up, and then I'm subtracting every single time, right? Now, instead of subtracting every single time, change this to a plus. What? Because adding a negative is the same as subtracting. Change this to a plus. Watch. 5 comes down. 5. 2 times 5 is 10. Add them up. Don't subtract. Add. Because I changed this minus into a plus. Okay, add them up. Negative 3. 2 times negative 3 is negative 6. Add them up. 4. 2 times 4 is 8. Add them up. Negative 1. There's my remainder. And this is my quotient. Number x squared. There we go. See? 5x squared minus 3x plus 4 is the same answer we had here. So that's called synthetic division. Okay? Synthetic division is completely okay to use. It's way faster than using long division. And yes, we are going to be using it. Okay? So what are the different steps here? So the first thing I did was I want to write out the polynomial coefficients in correct order. So write the coefficients in the correct order, right? And you know what? If there's zeros, you need to put them in. Next thing I did, instead of using minus 2, because I'm just not using any of these x's, I'm ignoring this x because that x ended up canceling every single time. What? Remember? The first term cancels every single time. Cancels. So, right? So that x is not the important. The minus 2 is the important part because that's what helps me figure out the next one. So I'm going to ignore the x and I'm going to change this. Instead of minus 2, I'm going to change it to a positive. So I'm going to negate, in other words, switch the sign, the constant in the divisor. Now notice I'm not using the x, I'm just using the constant. So next what I did, I bring down the first number and I go 2 times 5 and I multiply up to the next column. So bring down the first number, or the first constant. I'm going to multiply by the constant and place it in the next column. Multiply by constant, place it in the next column. Place in next column. This is why you want them in the right order, because I'll do this column and then this column and then this column and then this. Once I get them all done and I get my answers on the bottom. So once I place it here, I add these up and I continue the process. 2 times 3, continue on. So add up the column and then continue. Add up the column, continue your process. Oh, cool. This is way faster. It is way faster if the divisor is in this form of x plus or minus a number. That's why they call it x plus a or x minus a. So if not, then you know what? Long division is actually easier. What? It is. The reason we're doing long division is because this always works. Synthetic sometimes works. Sometimes. It doesn't always work. Sometimes if you're using a different kind of, if this was 2x minus 7, you're going to get a wrong answer. Okay? Synthetic will give you the wrong answer. Okay, so let's try this one though. This one's definitely going to work. 3, 2, 1, 15. Okay, so let's try this. 2x cubed, 3x squared, minus 4x plus 15. So those are my 4 coefficients. Okay, x plus 3, instead of going x plus 3, I'm going to go plus 3. No, I would be subtracting each time. If you negate this, you make it negative, then you can add, because adding is way faster. Okay, first one comes down, 2. Negative 3 times 2, negative 6. Add them up, negative 6, 3. Negative 3 times negative 3, positive 9. Add them up, positive 5. Negative 3 times 5, negative 15. Add them up, 0. In other words, the remainder is 0. And this is your quotient. So the quotient, q of x, is number linear quadratic 2x squared minus 3x plus 5. So in other words, if you took that quotient and you multiplied it by this remainder, or sorry, this divisor, you should get this polynomial. And it's true, you will. The remainder is 0. So that's all the work you need to show. So that's completely okay to do it that way. Okay, so let's try the next one. Divide by any method. I have a feeling that this one's not going to work because the divisor looks different. Now, let's say I actually did it. I don't trust you. I'm going to do it by 2x plus 1. I'm going to do it by long division. It's probably a good idea. It is. It's faster. Let's try it. 6x squared minus 5x plus 7. Okay, 2x divided into 6, 3x times. 3x times both of these, put them underneath. So 6x squared plus 3x, right? Subtract. Minus 5 minus 3 is minus 8x's. Bring down the 7 and start over. 2 divides into minus 8x, minus 4 times. Minus 4 times both of these, I'm going to get minus 8x minus 4. When I subtract, 7 minus minus 4 is positive 11. There's my remainder. This is right. There's my quotient, right? Q of x is this thing, and there's my remainder. Now, let's say I actually had done this thing by synthetic division, because I know, by the way, this is right. You just did this question and you got the same answer. Let's do this one by synthetic division, right? 6, negative 5, 7. Great. And they're in the right order. Great. So instead of, I'm just going to put 1, and I'm going to go negative 1. Okay, so remember, because I'm going to negate this constant. 6 comes down. Negative 1 times 6 is negative 6. Add them up. Negative 11. Negative 1 times minus 11 is positive 11. Add them up. 18. So there's my remainder, and there's my, hang on, that remainder is wrong. And the 6 minus 11, that's also wrong. Oh. What if you said this, 2 and then x plus a half? Okay, so when it's not just x plus a number, it doesn't work. This actually gives me the wrong answer. Okay, let's try this again. Yeah, what if you said, I'm not going to use 1, I'm going to use minus a half. Okay, let's try it. 6 comes down. Minus a half times 6 is minus 3. Add them up. Negative 8. Minus a half times negative 8 is positive 4. Add them up. 11. Okay. Now the remainder is right. But the quotient, it should be 3x minus 4. This is twice. Okay, so I have to divide this one by 2, but this one's right. If I was to divide this one by 2, but I already divided it by 2, that's painful. One of them will be right, one of them will be wrong. Okay. Why don't we just change the question a little bit? Hang on, instead of doing that, why don't I just say, this is the exact same as saying, divide top and bottom by 2, right? Yeah, you're right. Look, the bottom becomes x plus a half, and the top becomes 3x squared minus 5 over 2x plus 7 over 2. Okay, so now, sorry, there's an x. Now I can do my synthetic division with 3 minus 5 on 2 and 7 on 2. And instead of positive a half, I'll put negative a half out here. This is going to get ugly because I just did a whole bunch of fractions. This will work eventually, but you know what? This is way easier. If the divisor has a leading coefficient other than 1, you're better off doing it by long division, right? There's no fractions here, and this actually worked. It wasn't that bad. Yeah, it might work. If you don't divide top and bottom by 2, one of the answers is going to be right, one of them is going to be wrong, and you won't know. So for that reason, do it by long division. Okay. Yikes, look at this thing. Oh, this is a big polynomial divided by this. Okay, well, I could divide the bottom into, you could try and figure out two different factors, and then what you'd be doing is you're doing one of these factors into synthetic division, get your answer, and then you do the other factor into synthetic division, which, oh man, this is going to take forever. It's going to be a lot of work. That is possible. But you know what? If the divisor is not just x minus a, right? If it's x minus a, then synthetic division is your way to go. Yay! Because it's way faster. It's not. So you know what? Go to long division. But long division of this thing is not that bad. It truly is not. Trust me. This is the divisor. It goes out front. X squared plus 2x minus 5. Okay, what are we dividing it into? Okay, here we go. Make sure they're in the right order. 2x cubed plus x squared minus 19x plus 20. Okay, so instead of doing these as a binomial, I'm doing them 3 at a time. Yeah, instead of 2 at a time, you're just doing 3 at a time. It's going to work the exact same way. Really? Let's try it. Just look at the x squared, because remember, it's only the first term I want to cancel. X squared divides into 2x cubed 2x times. 2x times all 3 of these, put them underneath. Okay, 2x cubed plus 2x, 4x squared minus 10x. Subtract. You know what? These cancel. They do. Nice. 1 minus 4 is minus 3x squared. Minus 19 minus is plus. This is minus 9x. Oh, but I have a trinomial. Good. Bring down the 20, and you've got a trinomial. Now we just start over. X squared divides into negative 3x squared, negative 3 times. Negative 3 times all 3 of them and put them underneath. Okay, let's try it. Times here, negative 3x squared. Minus 3 times 2, minus 6x. Minus 3 times minus 5, plus 15, and subtract. Gone. Minus 9 minus 6 is minus 3x. 20 minus 15, 5. There's nothing else to bring down. That's my remainder. What? The remainder doesn't have to be just a number. In this case, because this is an x squared, as long as it's a smaller degree, the remainder could be an x term. Sure. So there's my quotient. There's my remainder. That's it. I mean, it was 2 steps. Yes, I'm doing them 3 at a time instead of 2, but you know what? In this case, long division is the faster way of doing it. However, if it's 2x plus 1, you're better off doing it by long division. However, if your divisor is x plus a number or x minus a number, this is way faster. Synthetic division is way faster. Okay, so these questions on page 124 all have to do with long division and synthetic division. And remember, if your divisor, synthetic, it is completely okay to be using synthetic if it's x plus a number, so x minus a, or x plus a number or x minus a number. But you remember, when you're going to put it out front, you want to negate that. So if this is minus a, I would make that plus a. If this is plus 7, I would make this minus 7 because it's way faster to add at each column. Alrighty, good luck with these, and this is the beginning of it.